Hello, ladies and gentlemen. I have very little time this morning, but there's something I keep thinking I'm finished with the South China Sea Impactor, and now I kind of just figured that the New Zealand vortex and the Fiji Island vortex just kind of were basically maybe cyclonic, and that's why you end up with the landmass at the core of those vortices. On the other hand, the more I'm looking at this, and what led me to look at this even more is I'm trying to figure out not Chicxulub, but Guacanayabo. Okay, so actually the central peak, if you want to call it that, I refer to it. It's not a central peak in terms of one little single mountain in the middle of a big circle. It's actually the pop, the point of penetration. So as I'm looking at this impact over here, this guy right here, I'm trying to understand because we have the badminton birdie, but this leg of the badminton birdie, this wing, is completely gone. Then you have what appears to be traces of a wing that may be crossing across here, which would indicate that this had occurred after this occurred. And yet I'm thinking to myself, I don't know. This is why this one's kind of a little tricky. But if I go here and look at this screen, because this is all that I have of the Jupiterian Stripes, my first mapping of Jupiterian Stripes based on the most prominent striations that we have visible to us on the planet right now. That's right here in the Pacific going through Hawaii. As you will notice, I'm going to go back to that. I know I'm going back and forth. Don't get dizzy on me, okay? This one is the central one. The Kiribati lithostream is the central equatorial lithostream, and because it's going in the direction that the planet is flowing. It is the only stream that is actually not a backflow. All these other streams, north and south, are backflows on Earth. And the sun, apparently, it's all going the same direction, just different speeds. Maybe that's how maybe they're not backflows as much as they are, but they look like backflows, so never mind. Anyway, we're coming over here at the Kiribati lithostream, all the way over here to the Caribbean on the right. And notice how the stream cuts straight through and severs right here. And when I say sever, this is what I'm talking about, ladies and gentlemen. That is your severage. How do we know it's a severage? Well, if we go in here and zoom in on this little guy right here, okay, you can see how it was cut right through here. Cut right through here, and that cut used to be a particular amount of possibly even continental mass. We'll call this material here continental mass because it's above the ocean, right? And it basically excavated this entire stretch of material and threw it out here to where it spins around like this. Now here's the thing: when we're talking about asthenospheric tsunamis, if you have an asthenospheric tsunami occur from or generate from the North Pole, it's going to flow southward toward the South Pole, which is down. Even though the planet is flying through space, kind of like this, okay? And this is the North Pole here and the South Pole down here. This is still up and this is down, all right? So that's just because of the way that as it turns out in my greater theories, it's the pressure. So not only is our parent black hole rotating our sun, it's also it's SME buffers, or it's SME gauze. I'm calling them SME gauze because I'm adding the gravity waves into the supermassive electromagnetic braided field ropes. Okay, I'm putting them all, and they're getting crushed together. I used to think that the gravity was pulling the SME buffers in, becoming SME gauze. No, but what it really is the gravity waves that generate their own gravity. Why? Because the vortex generates gravity. Okay, because gravity is the vacuum of space. That's why dark matter doesn't have gravity. So these waves are going like this. They're rolling just like waves on the beach. If you ever got caught in a wave on the beach and you're like in the laundry machine. Yeah, it sounded like that too. I know I was there. So anyway, they're rolling. So you've got this gravity. So they extend. They're like relay stations that extend the gravitational reach and influence from our black hole. So as they're coming through, they come through with a great force behind us, and they're pushing us through. And then the bow wave, as we've recently learned, is coming this way. Well, I'm not sure that the scientists have yet discovered exactly how that bow wave is striking the solar system, because from my understanding of the way the Voyagers went out along the plane of the solar system, not in front or above the solar system in a sense. So we've got these two forces going bam like this. This one is like the ground, and this one is the sky, and it's just pushing it forward, and it crushes our solar system into a disk. You get the same thing with the galaxies. Galaxies are crushed into disks by, one, universal jet streams, and two, the bow waves in front of those bodies that the bodies are being pressed into because of friction. Ta-da! Works really well. So, now I can't remember how I got to that. So anyway, this jet stream is the central one right here. The Kiribati is going right through here, and it severs right there. So when the energy that was released came through here and triggered this event, it was flowing in the direction of, you see this score right here, coming right through here. Wham! And it's not exactly straight, folks, because we got a lot of things going on around here. You know, the continents are kind of like they behave more like your kneecap, okay? And they can move around the synovial membrane. And so, go figure, I don't know the doctoristic name of frickin' kneecap, so yeah, whatever. Anyway, so the continents are free to move. That's why they get pushed around. Anyhow, at some point, you have the Sapaliwini force right here, that little dot, that's your vortical core, and it's rotating in this direction. The whole vortex is rotating in this direction. But the continent pivoted in a clockwise direction. And the reason these two continents pivoted in the opposite directions of their vertical rotations is because of centrifugal force and gravity pulling them down. So galactic gravity was pulling them down to the South Pole, while centrifugal force was pushing them out and spreading them, out toward the equator. Centrifugal force mostly tries to push things to the equator, but then in a sense it kind of gets recycled back. So this guy up here is a very confusing guy to look at, but I can tell you right now that this little bump right there is the pop. This is a B2W. How I'm going to try to work that in is going to be very very difficult, to say the least. All this twisted crap going on around here has something to do with what took place probably over here, and so we might actually have 10 asthenospheric tsunamis. So while the South China Sea Impactor triggered all these tsunamis up from the North Pole to flow south, it also generated energy that traveled across the planet at the equator, and bam, there's your freaking tsunami, right? That's why it severed this. This was not like this when this impactor struck. This impactor struck before any of this ever happened. So it probably stretched this, it completely eroded or destroyed this leg, the western leg of this impactor's B2W, and it stretched the eastern leg out and warped it. So, yeah. But you have this much of it, and so you can still get the top dead center point here and get these 2 points lined up and go, whee, there's where your poo is, right? And so, ladies and gentlemen, we can look at this big googity goo here, and it's about the same size as this guy here. So we could probably roughly assume that this is probably it's probably as big as Mount Rainier too. But the thing with this one is, now Mount Rainier, that's that little red dot right there, right? That's actually the red dot that created this crater. So if that little red dot made this crater, at the least, I'm telling you at the least here. Why? Because I can't find the first blast ring here. It's gone. Some things, I guess some things just do go away and you can't find them. Down here, this B2W and that pop look to be extraordinarily close to the same size. And here's what I'm going to do. I'm going to put those into PowerPoint, trace them, and then overlay them to see just how close they are. And if that's the case, then I can tell you really close to what the size of this impactor was. And it'll probably be alarming since the difference between 8.4 kilometers in diameter to 14.6 kilometers in diameter was the difference from the minimum to what this first blast ring gave us for this impactor. There could be a huge increase right here, and that means that yeah, I'm not sure if there's a mountain on the Earth that's in and of itself, you know, a cone shape, or you know, give you a circular base to give you an idea of the size of this guy, right? Excuse me. All right, so now you have Chicxulub going on up here, right? Here's my theory, ladies and gentlemen. That guy right there, yeah, I just don't know. This is where scientists, they got all the equipment, they got the federal lovey-doveys. Go out there, get your damn boat, and get a freaking core sample on that pop. Do it. Quit waiting around. Let's get some science done around here. So go down there, get that core sample, find out how old that guy is. Could this one have happened 65 million years ago? That's a scary thought, ladies and gentlemen. If this occurred 65 million years ago, then that means this one was even newer. Hello? Scary. How many years does it take for the world to recover from that stuff? That's why I'm saying this guy over here, Earth is still feeling the pain right here. And here's why I decided to make this video too. As it turns out, you've got this Indonesian, I think I called it the Indonesian asthenospheric tsunami. So it came down here, it swept down all the way from this fracture at the north in the Arctic. Came down, this was like the first one, the biggest one, right? And then your subsequent ones to create the Himalayas and all these other, Japan and all those guys. So this guy came down here, swept into this vortex as it filled the void, so to speak, right? And then this became the core up here of the vortex up here as the energy transferred from the point of impact to the foamy crap right there. So then it comes down here, and here's the scary thought. This stuff here almost made it completely to the South Pole. It kept flowing. It broke out of here. That's where, because I've been trying to figure this stuff out for the longest time, and it just dawned on me this morning. I know, I'm a little slow. It came down here. It went around Australia, because like I've said before, Australia was once Antarctica. You see that little arm right there? The funny thing about it is Australia couldn't keep the shape of that spiral density arm, and so it got severed, and centrifugal force is pushing it toward the equator northward. That's the only part of Antarctica that broke away as far as I can tell. So anyway, all this material came around Antarctica, and it's because of its rapid speed that you get these vortices coming around developing. So the South China Sea Impactor not only created Indonesia, it created New Guinea, it created Fiji, and it created New Zealand. That's the power of that impactor. Something like 14.6 kilometers in diameter. And that bugger reshaped half of our planet or more. Just figure out the landmass volume of how much it affected our planet. And it sent that it sent that energy straight across the planet this way because of centrifugal force. It couldn't go up, it couldn't go down, it goes across. Bam, severs, creates this asthenospheric tsunami here. How did I get onto that one? Well, because down here you have another litho stream that runs in this direction here, while Antarctica is rotating in this direction. It's rotating this way, which is what created this asthenospheric tsunami. And as the asthenospheric tsunami, I was thinking that it was because of the South American pivot and the Antarctic pivots that basically, or the Antarctic rotation versus pivot. This pivoted, this rotated, that created this wave. No, actually, these guys were probably already stretched into that position, and they may have even been connected right here, ladies and gentlemen, to some degree, or something. Well, you know, I don't think so, because this stuff, this guy here was wrapped up around here. Madagascar was pushed up into here. Africa was like landing gear on an aircraft was up in here. This guy wrapped around him. This guy got pushed in, and then they fell. Okay, but as you notice, these two are aligned. So what is that telling us? It's telling us that a planetary event occurred where the South American pivot, at the same time that Africa pivoted, and occurred when Antarctica became the most live, and it created Antarctica's most prominent spiral density arm here, where it tore away from this spiral density arm. Okay? And or that particular asthenospheric tsunami, I don't think that the South China Sea Impactor triggered this tsunami. Here's what I do think. Here it is. It's down here. It's right down there. Yep, there it is. So if you go around the planet, you follow this trail right around here. It kind of takes you right into here. Well, guess what? Guess what happened in here, ladies and gentlemen? You see this great big circle? That's right. I told you to look for circles. Darn, it's time to go. All right. There was obviously a very large impactor here, and it may have slightly reshaped Australia. And at this point, there's a linear series of 18 impactors going along this fracture. And this is what I'm referring to as the Battalion 6 in the Southeast China, in the Southeast Indian Ocean. All right? And so that's all I'm saying. You know, this guy here was a big guy, and this is the planetary butt, and we got slammed in the butt right here. Almost, it was like a butt cheek wound. You could have called our planet Forest. All right. Anyway, I gotta go now. That's all I have to say for this. I'm not even sure what I'm going to title this guy. All right. So I'll let you guys go. Okay, bye. Oh, yeah, don't forget to like and subscribe. I know I'm not the greatest spokesperson, but the information is what's important, right? Bye.